is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see distributed transverse load, combined bending, and in-plane loading. So in previous video, we have so the lecture topic will be distributed transverse load, combined bending, and in-plane loading. So in previous video, we had seen the bending moment equation, that symmetrical bending moment, how that will be there. We derived for mx and my, this moment along x-axis and moment along y-axis. Right. So now we will see how when the distributed transverse load will be there. Then what happened in the combined bending. Okay. So first about the distributed load and this one. So in general, the bending moment applied to the plate will not be in plane perpendicular to its edge. So just here, what we are applying the bending moment, right, will not be in plane perpendicular to its edge. So whatever the plane is there, bending moment we are not applying in the plane. So just this is the plate, right? What is there? In plane perpendicular to its edge. Perpendicular to its edge, like we are not applying. We are bending like this, not perpendicularly we are applying. Okay. Now, so may be resolved normally into tangential and perpendicular components. So after that, once we will apply like this, then you can convert into tangential and normal component. But directly we are not applying the normal tangent, this one, perpendicular to the edge. The perpendicular component are seen to be mx and my, as we had seen in the previous video. As before, while the tangential component mxy and myx. So now tangential will be what? This will be the perpendicular component. One will go up like tangential mx and my. This will be. But now once we will resolve the horizontal, so after resolving the horizontal of this force, what happens? This will go along the plane. Right. So this will be, if suppose this is x and this is y, then this plane will be xy and this plane will be yx. So you have to take care of which plane you are taking. So from here, this is x, this is y, this plane is xy and this plane is y. See the difference. This is xy and this is yx. Again, these are moment per unit length. So wherever this will be the mx moment per produces twisting of the plate about axis parallel to the x and y axis, that we had seen already, that mx is parallel to the y axis and my is parallel to the x axis, and this mxy and myx is along the plane. The system of suffixes and the sign convention for this twisting moment must be clearly understood to avoid the confusion. That's why this just how I explained that mxy and myx. So this is the mxy plane, means along x to y we are moving. So mxy plane, yx means y to x. So this is yx plane. So don't get confused with that one, which one mxy or myx, because the same plane will be there. This is the same, but which is mxy and which is my. So from x to y, I start from x and move like this along y. So that is xy plane. Now from the start from y and move along the x. So this is yx plane. mxy is a twisting moment intensity in a vertical x plane parallel to the y axis. So this will be what? Parallel to mxy is along the x plane, but it's parallel to y axis. Okay. Similarly, myx will be myx is a twisting moment intensity in vertical y plane. So in myx will be in vertical y plane, but parallel to the x axis. Note that the first suffix gives the direction of axis of the twisting moment. So first suffix like mx. So x will give direction and this will be parallel. So y is parallel to y axis. Similarly here myx means along the direction of y and parallel to x axis. Note that the first suffix gives the direction of axis of the twisting moment. So along which we are twisting. So in this case along y, in this case along x. We also define positive twisting moment as being clockwise when viewed along their axis. So once we will view along the axis, then if it's getting the clockwise, then the twisting moment is positive. Okay, of the corresponding x or y axis. Right. So depending upon which direction we are seeing, that we have to view along the direction. Right. And if it's clockwise, then positive. If it's anti-clockwise, then it's negative. Okay. So now here, let's use. So let's see, this is mx, okay, yeah, so this will be my, okay. Therefore all moment intensities are positive, since the twisting means all moment intensities are positive, either mxy or yx or mymx. So just here, Since the twisting moment are tangential moment or torque, they are resisted by a system of horizontal shear stress tau xy. So what happened? Twisting moment are tangential moment or torque. So twisting moment also produces force into perpendicular distance. That also is torque along the surface. Resisted by a system of horizontal shear stress. So now that torque will be resisted by what? A shear stress along the same plane, means tau xy. Okay. From a consideration of complementary shear stresses, mxy should be equals to what? Minus of myx. So mx means here along the x-axis perpendicular to y, and minus my means along the y-axis perpendicular to x-axis. So that will be just according to sign convention, it's negative. So that we may represent a general moment applied to the plane in terms of mx, my, and mxy. So in figure that we will see. These moments produce tangential and normal moment mt and mn on arbitrary chosen plane fd. So now what happened? Like here in this figure, this here the moment along this one, this sigma, or you can say mt will act, and along this that mn will act. Okay. We may express these moment intensity regarding mx, my, and mxy. So we can just present. Thus, for the equilibrium of the triangular element ABC in a plane perpendicular to AC. Now, suppose this is there, and from here we have taken this part. So that is A, B, C, D. Okay. So now one triangular part we have taken along the face AC. It's telling, right? So this will be the AC. Okay, perpendicular to the AC. So after that, what happened? This one. Yeah. Or just wait. Let me show you the figure. Just here that I showed you the figure. So along this face, or here A, B, C, D is there. So like this one. So here that is there. Okay. So this is the plane at angle alpha that is divided. So now you see here mxy is acting in the mx. Here mxy is there. Here mxy, that is negative. So just see, this is clockwise. So this is counter clockwise or anti-clockwise. So just see mxy and mxy. So this is actually myxy, because mxy equals to minus of mxy. So here one is clockwise, the other one is in anti-clockwise. Right? Now, and we are seeing that A, B, C, that force. So here my is acting, here mxy. So here the C, that mt I showed you along the face. So that is m tangential is acting, and here that m normal is acting along this face. So and what we have taken that at a distance z, dz, this is here. This we had seen in previous video. Also at a distance z from the neutral plane, we are taking that of del z thickness. Okay, so this is just AB, and along the A, B, C face, MT and MN is acting, and MXY. Okay, so now see the moment from that equation chain. MN into AC, that is MX AB cos alpha, that perpendicular distance of that AB cos alpha, plus MY into BC sin alpha, minus moment of MXY AB sin alpha minus MYX BC cos alpha. Now here giving that what, just divide with AC to all. So this we have what, MN. So now what happened with AC, we are dividing. So this will be MN by AC by AB by AC. I'm just writing here BC by AC, AB by AC, BC by AC. Okay. So now this AC will get cancelled. AB by AC, again from the figure we have to see BC by AC, AB by AC, and BC by AC. Right. So BC by AC is there. AB by AC. So now just see from the figure what we will get. From AB by AC. So this is what? This is base, this is perpendicular, this is hypotenuse. Right. So from here what we will get, that AB by AC, that is cos alpha, and AC by this is sin alpha. So just here we have to, okay, so here we have to apply the same. So after applying this AC, by AC, AB by AC, BC by AC, AB by AC, BC by AC. Okay. Now this AC get cancelled. AB by AC is what? Cos alpha from that figure. BC by AC is sin alpha. Right. AB by AC is again sin cos alpha. So now let's put here. So this is Mn equals to Mx. AB by AC is cos alpha. So cos alpha into cos alpha plus My. Okay. BC by AC is sin alpha. So sin alpha into sin alpha. Okay. Minus Mxy. Now AB by AC is cos alpha. So cos alpha into sin alpha. Minus myx. So minus myx. BC by AC is sin alpha. So sin alpha into cos alpha. So this is fine. This becomes cos square alpha. So from here we can write that Mn equals to Mx cos square alpha plus My sin square alpha. Now this is same. Mx minus Mxy cos alpha sin alpha minus Myx sin alpha cos alpha. Right. So from here what we can write? This as minus of 2, this one. Sorry. So this is minus 2mxy, okay, sin alpha cos alpha. So now this 2 I am taking this side. So here what we'll get? Mn equals to mx cos square alpha plus my sin square alpha minus mxy into 2 sin alpha into cos alpha. What is 2 sin alpha into cos alpha? Sin 2 alpha. So what we can write? Mn equals to mx cos square alpha plus my sin square alpha minus mxy sin 2 alpha. Okay, so that is here. Mn equals to mx cos square alpha plus my sin square alpha minus mxy sin 2 alpha. So this is Mn. Okay, means normal moment. Now similarly for equilibrium in plane parallel to CA. Now for plane parallel to CA we will take. So in the previous case what we have taken? AC. Now plane parallel to CA. So again write the bending moment. So just here. MTAC equals to MX AB sin alpha minus MY BC cos alpha. That MX is the distance and AB sin alpha is the distance of that one, that resolved distance. And MXY AB cos alpha, MXY BC sin alpha. Now again what we have to do? Just put or divide by AC. So after dividing by AC what we will get? MTAC. Okay, or just here divide by AC. I'm just dividing directly here. AC. Okay. Again AB by AC, BC by AC, AB by AC, and here BC by AC. So dividing AC both the sides. So this AC will get cancelled, right? So now what we have? That is MT, okay, equals to now MX AB by AC. AB by AC what we have taken, that is cos alpha. So here MX AB by AC is cos alpha. So cos alpha into sin alpha minus My. BC by AC. BC by AC was what? Cos alpha. Sorry. BC by AC was sin alpha. So here My sin alpha into cos alpha plus MXY AB by AC. AB by AC is what? Cos alpha. So AB by AC so from here, one second, sorry. So MX AB by AC is cos alpha into sin alpha. Okay. Then minus my BC by AC is sine alpha, my sine alpha into cos alpha plus mxy AB by AC. AB by AC is again what? Sine alpha into cos alpha minus mxy BC by AC. BC by AC is what? Cos alpha. So cos alpha into sine alpha. So let's just see here. Here there is no square term. Okay. So now from here what we can write? Just multiply and divide 2 by 2 with each term. So here 2 by 2. Or instead of this, I'm just here 2 by, or here 2 by 2. 2 by 2, 2 by 2, 2 by 2. Why? Just see here. With this we can write 2 sine alpha cos alpha and sine 2 alpha. So with this mx by 2 here, mx by 2 sine 2 alpha we got from here. Now from here my by 2 sine alpha. So minus my by 2 sine 2 alpha. Right, these two terms. Now from here again this and this will be same. So mxy common. Right. So mxy cos 2 alpha. Okay, sorry, here. This is AB by AC is sine alpha. So this becomes, sorry, cos alpha. Cos square alpha, and this is sine square. So this AB by AC is cos alpha. And this is sine alpha. So this will be what? mxy, or let me solve again. So this is here for this part. First we are doing this. So this is mx sine 2 alpha commons. Mx by 2 minus my by 2 into sine 2 alpha, or simply that you can write, that is mx minus my by 2 into sine 2 alpha. So first this first term we got. Now for this one, so here for this term, these two terms we are solving. So now mxy into AB by AC is cos alpha. So cos alpha into cos alpha minus mxy BC by AC is sine alpha. So sine alpha into sine alpha. Or mxy is minus of myx. So like that we can put here. So this will be mxy cos square alpha, and minus of minus this becomes, so minus mxy sine square alpha. Now take mx common. So mxy common, cos square alpha minus sine square alpha. So cos square alpha minus sine square alpha is what? Cos 2 alpha. So from here what we will got? mxy cos 2 alpha. So just here mxy cos 2 alpha. Okay, so first part we solved. The same way here you have to solve. You will get this one. Just you have to take care of this AB by AC values. Okay, so right, for which mt equals to 0, when mt is equals to 0, leaving normal moment of intensity mn on two mutually perpendicular. So when m tangential moment is 0, then what happened? Only the normal moment will be there. So intensity of mn on two mutually perpendicular plane, that is in xy. These moments are termed principal moment, and their corresponding curvature is called as the principal curvature. So when mt is 0, remember when mt is 0, only the two mutually, that normal forces will act, sorry, normal moment will be there on two mutually perpendicular axes, and that time that mn becomes the principal moment. Okay. So let's see once again quickly. Here, so we assume that here that mx and my is there. So along VC and ABC, that axis that we have to take in, that what was the figure, the triangle, sorry, ABC, this was there, right? So along this mn acting, and along the plane that mt was acting, here mx y, right? So now first along the plane MC, that AC, we have to find the moment. So MT into this AC, sorry, Mn into this AC, and for same whatever the tau x mx is acting. So now just see here, this, if this is alpha, then this distance will be what? This distance is AB, right? So AB, and this is BC. So just take in terms of AB and BC, because AC we don't know. So AC we have to remove. So AB, this term will be AC sine alpha, and this is, sorry, AB sine alpha, and this is BC cos alpha. That you have to just take into the moment form, and then you have to form the equation. So here, Mn into AC, along the x-axis AB cos alpha, and for y, BC sine alpha. Just stop. So minus mxy AB sine alpha minus myx BC cos alpha. Now here what you have to do, just divide with AC. Okay, so after dividing AC, this term is free from AC. So Mn AB by AC is cos alpha. So cos alpha into cos alpha square, or cos square alpha. Sorry. MYBC by AC. BC by AC is sine alpha. So sine alpha into sine alpha means sine square alpha. So MY sine square alpha. Now here minus MXY AB sine alpha. So AB by AC is cos alpha. So AB by AC is cos alpha means MXY cos alpha sine alpha minus MYX BC by AC is sine alpha. So MYX BC by that sine alpha into cos alpha. Now this will get added. So this will be minus 2MXY sine alpha cos alpha, and 2 sine alpha cos alpha is what? Sine 2 alpha. So that becomes minus MXY sine 2 alpha. Similarly, for equilibrium in a plane parallel to CA. Now along the plane CA we have to take. Okay, so again same moment 1. So MT into AC equals to MX into AB sine alpha minus MY into BC cos alpha plus MXY into AB cos alpha minus MXY into BC sine alpha. Next step what? Again divide by AC. So AC will get cancelled. Here MX AB by AC sine alpha. AB by AC is cos alpha. So MX sine alpha into cos alpha minus MY BC by AC is sine alpha. So MY sine alpha into cos alpha plus MXY AB by AC is cos alpha. So this becomes cos square alpha. That MXY cos square alpha minus MXY BC by AC is sine alpha. So sine alpha into sine alpha square means MXY sine square alpha. Now here just with this divide 2 by 2. So now this becomes 2 by 2 means M square AB sine alpha by 2 MY 2 sine 2 alpha by 2. After taking sine 2 alpha common, what we will get? MX minus MY by 2. Or let me show you once again there. So here first these two terms we are doing. So this will be MX into AB by AC. AB by AC, first let me write AB by AC sine alpha minus MY BC into cos alpha BC by AC. So this is MX AB by AC is what? Cos alpha. So cos alpha into sine alpha minus MY BC by AC is sine alpha. So sine alpha into cos alpha. Now here multiply by 2. Okay. So this will be what? Or just take cos alpha by 2, or simply here MX minus MY, okay, into sine alpha into cos alpha. This we can write after taking sine alpha cos alpha common. Now here multiply and divide by 2. So MX minus MY into 2 by 2 sine alpha into cos alpha. So this 2 sine alpha cos alpha is what? Sine 2 alpha. This is 2 here. So this by 2. So MX minus MY by 2. This 2 here into 2 sine alpha cos alpha sine 2 alpha. So sine 2 alpha. Now in this case what we got? MXY AB, this one. So MXY cos square alpha minus sine square alpha. Take MXY common. So now what we will get? Cos square alpha minus sine square alpha. Cos square alpha minus sine square alpha is what? Cos 2 alpha. So MXY cos 2 alpha. So now this is the MT. Now we found Mn and MT. Mn is here empty is here. So for which empty equals to 0, when empty will be equals to 0, that time what happened? Only the normal forces, normal moment will be there. This is right on two mutually perpendicular plane. These moments are termed as principal moment. So when empty is 0, then only the normal moment will be there, and that normal moment is termed as the principal moment. Okay, so this is again the reference which you can refer to as G mentioned, aircraft structure. Okay, so same book you can just refer. Okay, so if you have any doubt regarding this concept or any calculation or how to take the moment, you just comment on the video or you can contact me. I will clarify your doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.